do they simply collaborate on a problem? Or is one class made up of members from another class, and so on? And we could think of examples of all sorts of things. For example, in our pizza example, our order class was made up of pizzas. All right, that's called composition. Composition is whenever you have one object containing one or more other objects. In other words, those make up the order object, a list of pizza objects. Okay, the one thing we're going to look at today, one tool that we use that we're going to look at today, is called a Clapgram. And there's slight variations in how people do things. I'm going to show you how I like to make class diagrams, and we'll go from there. All right. You certainly go through this and read it in more detail. I'm not going to read over every line. Here's sort of the key points of this. In this, you see that there is a customer class, an order class, a special order class, and a normal order class. Now, as you might imagine, the special order and the normal order are specialized versions of the order class. In other words, they are subclasses of the order class. That is shown in a diagram by drawing sort of an arrow pointing to one from the subclass up to the superclass. So notice that a special order is an order, a normal order is an order. In object-oriented terms, the subclass are special order and normal order. The order class is the superclass. And depending on the direction you can look at it, you can call it generalization or specialization. If you're looking at it from the order to one of these two classes, it's specialization. This is a specialized version of the regular plain old order. If you're looking at it in the other direction, an order is a generalization of these. It's a more general version of it. All right, so it goes either way. But the key thing to remember on this is that there's arrows. Now, the one thing they did here is they listed the attributes and the methods that each of these classes have. All right? And they repeated them. In other words, the date and the number of the order, they repeat in the special order and the normal order. I normally don't do that. When I draw a class diagram, I typically only show the things that are defined in that class. So if the date is defined in the order class and is inherited by these two classes, I wouldn't show that date in here as well. All right? By the same token, confirm, close, and so on, unless they override the methods in this class, I wouldn't show them either. All right? I wouldn't show them either. Unless, of course, they override it. Yes? Yes, the dispatch would be shown in the order, because it looks like that is declared on this level, that all orders have some form of dispatch. It is similar in some respects to normalizing, but there's really not there's not so much the equivalence of inheritance in databases. There is a little bit, but you could call entity subtypes as similar to inheritance. But like this part of it, whereas and what they don't show here is that an order has a customer associated with it. So I would actually show that there's a customer over here. So I do that a little bit differently than they would do it here. In a way, yeah. It's mainly for planning and for figuring out what classes you need. The idea is that as you're drawing these things, you may notice that a couple of classes share a bunch of attributes and share a bunch of methods, especially methods. Where there's methods that are shared, there's a good chance that there will be inheritance. Excuse me. Not necessarily attributes so much. I mean, because a lot of things, for example, have a name, address, city, state, zip. That doesn't mean that they're all related inheritance-wise. But if you notice that things share common methods, that sometimes is a tip-off to you that, oh, maybe we have an inheritance situation here. Okay? So, let's go, and with that, let's consider a scenario. I'm going to draw the object diagram for it, and then I actually already have the code, but we'll write some test code to test it. All right? So let's look at a situation where we're going to consider different kinds of sales reps. Excuse me. Let's say we have a sales rep. We have a junior sales rep and a senior sales rep. All right. So I'm going to write some facts here about each of them, and then we'll talk about the object-oriented design that we have. A sales rep has associated with them an employee, a name, and a sales amount. We'll say that's how much they sold for a month. Okay? For the sales rep, there will be gets and sets for each of these. So there'll be the ability to get and set the employee, the name, and the sales amount. Sales rep have a base salary. So they have a method to get base salary, which for a sales rep is $2,000 a month. They also have a get commission method, which is 10% of their sales. Then total salary is their base plus their commission. So if a sale sold $100,000 worth of goods in a month, that's a lot of money. Let's say they sold $10,000 worth of goods in a month. All right? Their total salary would be what? Well, their base salary is $2,000. Their commission is 10% of what they sold. If they sold $10,000, their commission would be $1,000. So their commission would be $1,000. So their total salary would be $3,000 per month for that month. All right. Of course, it's going to depend on what their sales are on any given month. Let's say we have a junior sales rep. I'm just gathering the facts now. I'm not doing any object-oriented design. I ask people, well, what do you need to know about a junior sales rep? Well, they also have an employee ID, a name, and a sales amount. And of course, they're going to need gets and sets for these. And they and it's $1,500. And they have a commission, which is 0.075%. And their salary is equal to base plus commission. All right? We have the senior sales rep. Guess what? They have an employee ID and a name and the amount that they sold. They have those properties. They get the base salary, which is $2,500. And their commission is either, what is 12.5% plus an additional 2.5% for any amount over 10,000. So in other words, if they sold 12,000, they'd get 12.5% of 12,000 plus an additional 2.5% for the amount over 10,000, which would be, I don't remember what I said, 12,000, which would be 2,000. They'd get the additional 2.5%. Okay, so these are the three things that we need to build. All right? These are the three things that we need to build. Let's think about drawing a class diagram. First of all, how many classes do we have? And don't laugh. There's always more than one answer. But you say 3? And that's the answer I like. There are people who might say, just make one class with a type of sales rep associated with it. And then have if statements that would say this, that, and the other. That's not a horrible approach, but it's not really in keeping in the spirit of object-orientedness, where you consider, is this an example of that, or is this a type of that? And I think you'll find that you'll have a lot more simple, straightforward code if you take the approach of making 3 classes. But question the obvious, maybe that seemed an obvious answer, but there are alternatives to it. All right? But you're right, we're going to go with 3. What are those 3 classes? Exactly, the 3 different sales reps. So I'm going to write something like this. Sales rep. What inherits from what? I should ask that before I started writing. Yeah, junior and senior inherit from sales rep. All right. Because use the is a test. Is a junior sales rep a sales rep? Yes. Is a senior sales rep a sales rep? Yes. So sales rep then is the superclass. It's the more general term, and the more specific versions of that are junior sales rep and senior sales rep. So we'd draw it to look like this. Now there's a couple ways that we could do this. I'm going to pick one of them. I'm going to start by trying to know the attributes that exist here. And there is an employee ID. There's a name. And there was a sales amount. It's kind of a marker to write with. I'm going to switch over to the thinner marker. Now, are there any attributes in the junior sales rep that aren't in the regular sales rep? No. So there's no different attributes for either junior sales rep or senior sales rep. So I'll just leave the attributes blank. Now it's going to be get attributes, get and sets there. There's going to be get base salary, get commission, and get total sales here. Which of those do you think we could override, or do you think we should override for the junior sales rep and the senior sales rep? The commission. So get commission is going to be different. Because both of these different sales reps have a different way of calculating commission than the sales rep does. Okay? What else is different? The base salary. So get base salary is going to be different. Will the gets and sets be any different? Do we have to override those? Shouldn't, right? All of them have an employee ID or an employee number, a name, and a sales amount. Really nothing worth overriding. No reason to override that in the subclasses. What about calculate total salary? Does that need overridden? Okay. Anyone disagree with that? Yes.
Aren't you still just adding the
right. In both cases, you get the base salary, you get the commission amount, and you add them together. So you're right. The commission's going to be different. The base salary is going to be different. But we've already overridden those. So the get total salary is still the same thing. Just add the two together. So we can code these cases simply by overriding those two functions. All right? Now again, there's other ways we could do this. I don't want to imply this is the only way to do it, but I wanted to demonstrate this way. So we're coding the differences. And in my opinion, that's what you show on a class diagram. You show the differences between the two. All right? This is a sales rep, all the attributes and methods. These are the methods that are different for a junior sales rep. These are the methods that are different for a senior sales rep. So that's what a diagram looks like. So let's go and look at the code for this. I'm going to start out looking at my sales rep. And my sales rep, I have an int for employee ID, a string for name, and a double for sales amount. And I have sets and gets for all of them. And calculating the commission, which is 10%, for base salary, which is 20%. I'm sorry, not 20%, $2,000. Now, I wanted to keep this like real simple. Maybe the base salary for a salesman depends on how many years they're there. Maybe it's $2,000 plus $100 for every year they've worked here or something like that. All right, so it could be more involved than this, but I just wanted to keep it very simple. And then total salary, which simply adds those two functions, the results of those two functions, and returns that. Okay? I don't have any constructors in this. We could talk about constructors when we're done. All right? But I just wanted to focus on methods and attributes in this example. So what do I code in the other two classes? I code the differences. So for senior sales rep, it is sales rep. Means that a senior sales rep is a more specialized version of a regular sales rep. What do I override? I override the two methods that I said were different. The get base salary, which again could be a complicated formula. I simplified it as just being $2,500. And then finally, get commission, which is 12.5%. And anything over $10,000, you get an additional 2.5%. So effectively, you make 12.5% up to $10,000, and then you make 15% for amounts over $10,000. And junior sales rep, get base salary $1,500. Commission is 7.5%. Okay, let's create a test class for this. And let's create a test class and let's run through some scenarios. All right? Let's think a minute. Let's think for just a minute. How many different test cases do we need to make sure that our code works? A test case is what? Well, let's look up because I have a definition of test cases. A test case is a document which has test data, preconditions, expected results, and postconditions. So there's a scenario. I say how to test it, I say what the results should be, and I say what the actual results are. So one line of this, one scenario I might want to take is I have a junior sales rep. All right? What would the test step be? Well, if I had a GUI, I would say create a test that contains a junior sales rep, put in the salary or put in the amount of sales and test it. But I'm test class now and I'm hard coding that. So my test step might be enter create a junior sales rep object, give them a sales of $5,000 and their base salary should be $1,500. Their commission should be $5,000 times 0.075 should be $375, and therefore their total salary should be $1,875. And I that in my test cases. Scenario is test junior sales rep. Create an object, create a junior sales rep object. Initialize the sales to $5,000. What am I expecting? I'm expecting a base salary of $1,500, a commission of $375, and a total salary of $1,875. Then I look to see, did it work? Did I get that result? So let me make a test document here, and I'm going to make it in Excel. So I'm going to say test case number 1. Create and the scenario is a junior sales rep. Steps. Create a junior sales rep object. Sales equal $5,000. Expected. Base equals 1,500. Commission equals 375. Total equals 1,875. So this could be one test case, and then I with the and see what the results are. happens that I change my code? Guess what? I run it through these tests again. All right? If I touch that code and it didn't mess anything up, it just takes a second to run this, right? I've heard people say, why would I bother testing it? I know I didn't touch that. Do you know how many times I've heard programmers say, I know I didn't touch that piece of code, and yet there's been a bug introduced, and when you kind of figure out what happened, it's like, oh yeah, I forgot about that, all right? Again, verify, test, make sure. So I would write these up, and I would write up all the other conditions that I wanted to test, all right? This is just one of them, and I'll test it, and I'll create a test class, and I'll put it in here, and then we'll talk about what other test cases you might have. So let me go and create a test class. I'll call it unit test. So, test cases tells virtually what we have to do. Create a junior sales rep object. Set the sales to $5,000. Then ask what's the base salary, what's the commission, what is the total salary. So, test case 1. I didn't create any constructor, so I have to use the no argument constructor. I do have my sets, though, so I can set the properties. Okay, so this is a code that represents test case 1. I can go and match it up with my test plan. I'm going to go save everything, and I'm going to get into the appropriate folder and run this. So okay, there they are. I can compile these. All right, cannot find symbol. And that's in the sales rep. And, okay, let's look in set ID. So 2 errors. EMP ID. Okay, it's saying sales rep 19, return can't find symbol. Yeah, they're both capital. All right, that's one. And the other one is set ID. And yeah, that's set ID with a capital. All right, now I want to run this. Public static. All right, look, that's right. That's the actual results I got, finally, after a couple of errors. So I can put in here the actual results are base equals 1500, com equals 375, total 1875. Whoops, typed that wrong. And I can have an either column or not that says bug. And if there's a bug, I can put a check saying, hey, that didn't work. So someone needs to take a look at that. All right? This is a systematic way. Far too often I see that people test things in a very haphazard way. They may create a couple of objects, run it, and see, oh, that looks right. Well, you know, that's not a good way to find errors. All right? You're really rolling the dice, and you might find them in some cases, and you might not find them in other cases. So a better way is to think through systematically and try to determine what the possible errors are. Now, all right, how many test cases would we need for this for us to be confident that this works pretty well? All right, 3 is a reasonably good answer because we have a test for junior, test for regular sales rep, and a test for senior sales rep. Anyone have a slightly different answer? 4. And why do you say 4? Right. Because there's we look at the code here, there's there's 3 different classes, right? Junior, senior, and regular sales rep. So that's at least the 3. But if you look at the senior sales rep, there's sort of a split, all right, between, to 2 different types of senior sales rep. There's a senior sales rep that sells up to $10,000 and the senior sales rep that sells over $10,000. This is known as white box testing, all right? What do we mean by white box testing? It means that we're the programmers, we know what the code does, we know where there's if statements, so we're going to take a peek in there and see what's the important things to test, all right? Some people don't believe that that's a good idea. Some people would say you should do black box testing, whereas you don't know anything about what the code, you pretend not to know anything, or maybe you have a different person testing that truly doesn't know anything about the innards of the code. And then they just test a whole bunch of scenarios and come up with that. White box testing, I think, is a good compromise because you know then what the borders you have to test in. Now, I might tell, 4 would be the minimum, I would say. I might actually test an additional one to make sure right on the border it worked. Yes?
I was going to say exactly 10,000.
Yeah, exactly at 10,000, maybe $10,000 or $10,001 or something like that. So you're right at the border, right below the one category, right above that. So 4 or 5 would be a decent answer to how many scenarios to test. If you're not testing those, you don't know that it worked, all right? You may be pretty sure it works, and you might look at the code and say, yeah, that works, yeah, that's reasonable, but until you actually test it, you don't know for sure. Really, that's where programs and programmers get in trouble, is that this is just a very, very, very small, little, tiny example. But we had the additional case of, well, there's some kind of senior sales rep that sold a low amount, some that sold a high amount. And you need to test each of those. All right? When you start adding things in, that's when things get really, really difficult. Like, for example, going back to the tuition calculation, you had 3 groups, in county, out of state, but then you also had 3 credit hour groups, 1 through 12, 13 through 18, 19 and above. So that's at least 9 things. And if you test on the border, like we suggested, you could get up to 12 or even more. That's why the student that actually created a loop to loop through and comprehensively test it, that was brilliant. All right, because then you can look at the chart and make sure that for every, there's only 60 test cases. If you write a loop, that's not a lot to test every single individual test case. Something like this, it would be difficult to test every possible value, but you would test within ranges of values. The point is the one thing I want to focus on in this class, one thing I want to emphasize in this class is testing things and testing things thoroughly, all right? Because that's really a good skill to have. Even if you have a quality assurance department, let's say, that's responsible for testing at the organization you work for, you want to test things as thoroughly as possible so when you release it to QA, they're not finding little tiny issues that you should have been able to catch on your own. It really is disheartening for me when people turn in stuff and stuff just doesn't work. It just doesn't give correct results. It compiled cleanly, it gave you a number as an answer, but you need to go through and test for all the different conditions. So for future assignments, I may actually ask for a test plan. And a test plan would be something like this, with a list of all the possible scenarios that you're going to test, what the expected is, what the actual outcome is, and making sure that they're all in agreement. Again, if I go and change something, if I decide that there's a bug in such and such code and I want to revise it, I can run, if I create this test class here, I can just go rerun it again with all the different test cases in it. Look at, do my results match? Yes, they do. Okay, I didn't break anything. And that's really a big concern. That's called regression testing. You know, when you fix one problem, you don't want to cause another problem. So how do you ensure that? You test for it. Don't rely on the fact that, well, I'm pretty sure I didn't touch that code, or I don't see how changing this could affect that. In large programs, it's really hard to tell if you change something, are you going to affect something else. Ideally, you won't. If the program is designed very well, you probably won't. But test it. If you've done everything correct, it's only going to take you a minute to test anyhow. So why not take the extra time and be really, really certain? All right. Any questions over any of this? We'll talk about some more stuff relating to inheritance. We'll talk a little bit about dates, and then we'll go from there next time. All right, we'll see you up in lab.